Hi everyone, this is Geeta. Today we are learning about the topic is support vector machine in and machine learning. The topics we are discussing are introduction to SVM, how does it work, and the SVM parameters, advantages and disadvantages of SVM, applications, variants, and the main conclusion of this SVM. First, introduction to SVM. SVM is a powerful machine learning algorithm. It is used for both classification and regression tasks. In these both, the most used is classification problems like text classification, image classification, and bioinformatics. In this SVM algorithm, the powerful machine learning algorithm, first we will plot each data item as a point in an n-dimensional space, where the n-dimensional space is nothing but where n is the number of features you have, with the value of each feature being the value of a particular coordinate in an graph. Then we will perform a classification by finding the optimal hyperplane. Now, this optimal hyperplane will differentiate the two classes. How does it work? SVM it is a binary classifier. This separates the data into two classes by finding a hyperplane that maximizes the margin between the two classes. The margin is the distance between the hyperplane and the closest data points from each classes. Where in an SVM network, first it is a binary classifier. It separates the data into two classes by finding the hyperplane, where this hyperplane it maximizes the margin between the two classes. Then the margin is distance between the hyperplane and the closest data points from each class. SVM can also handle non-linearly separable data by transferring the data into higher dimensional space. Now, first we are identifying the right hyperplane. Here we have three hyperplanes like A, B and C. Now firstly we should identify the right hyperplane to classify the stars and the circles. Select the hyperplane which segregates the two classes better. In this scenario, hyperplane B has excellently performed this job. Then in the identifying the right hyperplane scenario 2, here we have three hyperplanes like A, B and C all segregates the class as well. We identify the right hyperplane. Here maximizing the distance between the nearest data point and the hyperplane will help us to decide the right hyperplane. This distance is called as margin. Next, maximizing the distances between the nearest data point. Here, the hyperplane will help us to decide the right hyperplane. This distance is called as margin. Here we can see that the margin for hyperplane C is high as compared to both A and B. Hence, we name the right hyperplane as C. Another lightning reason for selecting the hyperplane with a higher margin having is robustness. If you select a hyperplane having a low margin, then there is a high chance of misclassification. In this scenario below, we can't have a linear hyperplane between the two classes. So, SVM classified these two classes. We have only looked at the linear hyperplane. SVM can solve this problem easily. It solves this problem by introducing additional features like we had a new feature like z equals to x square plus y square. Now we will plot the data points on axis x and z. Then we will calculate the by adding a new feature z equal to x square plus and y square. These plot points to consider are all values for z would always be positive because z is the squared sum of both x and y. In an original plot, red circles appear close to the origin of the x and y axis. This leads to a lower value of z, where the star is relatively away from the original traces, where this is because of the higher value of z. SVM parameters. C is a regularization parameter where the C controls the trade-off between maximizing the margin and minimizing the classification error. Then gamma is a parameter where this controls the shape of the decision boundary, and the high gamma values will lead to more complex decision boundaries than less gamma values. Kernel function, it is a function that transforms the input data into an higher dimensional space. The common kernel function include the linear, polynomial, and the radial basis functions. The main SVM parameters are the C, gamma, and the kernel functions. Advantages and the disadvantages of the SVM. Where the advantages are SVM can handle the high dimensional data and the datasets efficiently. Then it is robust to overfitting due to its ability to control the complexity of decision boundary. It can also handle non-linearly separable data by using the kernel functions. These are the advantages of the SVM. Then disadvantages. It is very sensitive to choose of kernel function and its parameters. It can be computationally expensive for large datasets and complex to kernel functions. SVM does not provide probabilistic outputs which will be necessary for certain applications. These are the advantages and disadvantages of the SVM. Now, the applications of SVM. The main applications of SVM are image classification and the text classification and the bioinformatics where we learn in the first topic introduction. Here, the image classification it explains SVM has been used to classify the images based on their content, like detecting objects in an image. And the text classification SVM has been used to classify the text documents into different categories like spam filtering or sentiment analysis. Then bioinformatics. SVM has been used to classify the genes based on their expressions, patterns, or predict the protein interactions. So the applications of the SVM and the variants of SVM are three types. One class SVM and the support vector regression and multi-class SVM. In an one class SVM, it is used for anomaly detection by finding a hyperplane. This encloses a single classes of data points. Then support vector regression. Here it is used for regression tasks by finding an hyperplane that minimizes the distance between the predicted values and the actual values. The support vector regression it's mainly used to find and minimize the distance between the predicted and the actual values. Then final one is multi-class SVM. It is used for multi-class classification by constructing the multiple hyperplane to separate the different classes.